Welcome to Rocketry at University High School. I'm joined by Melvin Wall and his team, and you're getting ready to go to Fredricksburg, Texas for an important event. Can you tell us what is that event?
The event is to just have fun and launch a bunch of rockets.
Now, is this something that you've just whipped up in a week, or how did your team create this rocket?
The first step of creating the rocket was to go on a program called RockSim, otherwise known as Rocket Simulation. And you pick the materials that you want, how big you need them, how long, like what all is needed for the materials. And you basically build it from there. Our task was to have a rocket that would fit a 1-pound payload and go up to a mile. So when building the rocket, we noticed that we couldn't just pick materials like what we wanted, like say carbon fiber, quantum tubing, cardboard. We couldn't just pick things. We had to focus on the motor first, so to see like if it was going to be powerful enough to carry a rocket and the 1-pound payload.
And all of this was done on the computer simulation prior to ever coming in the room and building.
Yes, we did all of it. Once we finally figured out that it's making it to the mile, it's being able to carry the payload, it's not going to tear itself apart, it's not going to go up and then come straight back into the ground, that's when we knew we can start building.
Okay, and I know you said your team is adding on a little something to the rocket.
Yes.
What are you putting on there?
We're putting on a, can you hand me the, we're putting on a 1-pound camera on here, so we're going to be attaching it right around right here so we can watch the amazement that is the rocket flying off. We get to watch the motor ignite and just fly off.
Now, what is a successful launch called?
Just a accomplishment, a successful launch, just pretty much like that.
And if, for whatever reason, not that this would happen to any of our teams, but if it wasn't to go so well, what do you call that?
A catastrophic failure.
And that's not an understatement. That's actually what they call it, is a catastrophic failure. Can you introduce us, Melvin, to the rest of your team?
Yes, ma'am. This is Esteban Esquivel, Cheyenne McGeehee, and Anna Gonzalez.
Well, good luck, guys.
Thank you, ma'am.
Thanks. You've had a great construction, and I love the colors, like the purple and the gold. So now we're going to go ahead and we are going to talk to the second rocketry group. This is Rocketry 1. And Jeremiah, can you tell me who's with you?
This is Monty, Anna, and Tiandre, and they all helped build the fins.
Okay, now the fins, what is the body of the rocket made out of?
It's carbon fiber, and we just put a clear coat on it to make it shine.
So, and then now the fins on there, what makes those fins special?
Because they're aerodynamic fins, and since they're circle, the air is just going to flow through the fins, and it's going to make it easier to fly.
Now, was that the easiest thing to attach those fins to the rocket? How did you do that? Was it?
We used wood-based filler on there and to make them attach, and we had to file them down for days to get them actually smooth to where it would not show any lumps and it would be easier to fly.
Now, about how many hours would you estimate of sanding wood filler?
Well, it's about an hour period, and we spent about 2 weeks.
Wow, so probably about 10 hours. Now, what is this fun thing in your hand?
This is an altimeter, and it's used to count the measurements of not the measurements, but how fast the rocket is going, how high it's going, and about what time it reaches the speed that it's supposed to be. And we're supposed to be taking it to a mile, and this is the start button here. And it also can be used to eject a parachute from here.
Okay, and then you would recover this at the end of the launch? Well, that is incredible. And I know you're also trying to carry a 1-pound payload. And the first group is carrying a camera, but your group is carrying, I understand, it is a 1-pound gummy alligator. That's awesome. Well, good luck next week. Thanks. And now we're going to our Rocketry 2, and we are joined by Curry. Now, Curry, this is not your first year at the rocket launch.
No, I also did last year. I was in Rocketry 1, and I did a 1-pound. This year, I'm in Rocketry 2 doing the transonic rocket.
Okay, a transonic rocket. What was your goal or mission in building this rocket? Because it's a little different than the 1-pound rocket. What are you trying to accomplish?
We are trying to accomplish to break the sound barrier. We want to go through it, and it's pretty hard.
So now yours looks a little different than their rocket, and I know it's not painted yet, but what is this material and why is it different?
Well, this material, it's fiberglass, and fiberglass is a lot lighter, which means it weighs less, and also it's a lot stronger, so that way it can withhold the pressure of going through the sound barrier, and it won't collapse or break or anything.
Now, I understand this is your second prototype that you've done. The first one, you made some changes to the design. What was different?
Well, the first one we had 6 inches in diameter, so it was a lot wider. But the problem was we didn't account for the weight of the parts, so it weighed a lot more than in the simulation. So we had to reduce our size to 4 inches to reduce the weight.
Well, that's really nice that you did that and like you made all of those corrections before the actual launch. So, what are some things that the guys are working on right now?
Well, Chris is over here. He's working on our altimeter component. It's where the altimeter is going to go in. He's sanding it so that way it'll fit smoothly.
And that's the case that the machine goes kind of into,
Yeah,
so
it
kind of
goes
like
into.
okay.
Yes, and then we have Ethan. He's working on our altimeter. He's our electronics person. And then we have Isaac and Robert. They are sanding the body so that way we can start painting and have it smooth and ready, and also so that way there's no bumps. So when it goes through, there's no like malfunctions.
Okay, so the smoother it is, the more aerodynamic, the better performance.
Yes, we want it as smooth as we can get it.
And who else is with you?
And then this is Jessica, and she's with recovery. So she helps with like all the parachutes and putting them in and getting the right sizes that we need.
Thank you, Curry. And now these 3 groups are led by an incredible instructor here at university. Hi, Mr. Dennis Oob. Can you tell us a little bit, Mr. Oob, do these kids come into your rocketry class just knowing what to do?
Oh, heck no. I mean, when we get them, they're usually in 10th grade or 9th grade, and they don't know anything about rockets. So we have to teach them all the way the basics from what is a rocket all the way up until you can see advanced mathematics and advanced rocketry.
Now, what do you start with? Do you start on the computer simulation, or do they just get to come in here and start building right away?
They start building right away. So early in the semester, after the first couple of weeks, we start right in with modeling and building from scratch. And so that's really the hook for this program, is that they get to start very early working with models.
Now, the first rockets that they build, how high do those go?
Oh, those models usually go everywhere but up. Because they don't really know anything about stability yet. So the first rockets they build go everywhere. Some of them go up, some of them don't.
So trial and error.
That's right.
Okay. Now, can you tell us a little bit about what you're going to expect at this rocketry event in Fredricksburg? What's it called?
Okay, rocketry. The rocketry classes work for something called Systems Go, and it's in Fredricksburg, Texas, and it's an event called Rockets 2014 this year. And it takes place every year around in May. And we have approximately 50 to 60 high schools throughout the state of Texas that participate. And in this high school, we have 3 rockets. At our Greater Waco Academy, they're going to have 4 rockets. So we have 7 coming from the district this year. And so, you know, every high school in the state of Texas has rockets going out there, either 1, 2, 3, sometimes 4 rockets.
That's incredible. And are there anything that you would want people to know about the hours of hard work that these kids put into the rockets?
Oh yeah, I mean, we break it into teams where the students are working in teams, and so the workload is not really that high on an individual student because you're working in your little small teams. What I like them to see is how it all comes together in the end. Every team does their little part, and in the end you have a beautiful product once you're done. And so that's what this class is really all about.
Yeah, I saw in the advanced rocketry group where they had people broken down into specialized parts, where it was recovery and on the add-on equipment, and then people that were the electricians for the team. And so the kids get to maximize each other's strengths.
That's right. And it takes place, and for your weaknesses too, because not everybody's good at artwork. And so you have people that will take care of that, and people that are good with electrician, they take care of that. So yeah, it's really good to see like the project come together at the end. And then, of course, the event at the end, which is kind of the culmination of everything.
Well, good luck in Fredericksburg. I hope everything is successful in your launch. So congratulations with everything that you've done with these students.
Well, thank you so much for coming today.
Thank you for watching WISD TV. Learners today, leaders tomorrow.